Alright, so what I want to talk about today is going to be section 5.1, area under a curve. So the whole point of this section is that given some kind of curve, on some finite interval, here's f of x, there's y, there's x. The whole question is, okay, what is the area that's between the curve and the x-axis? Meaning, what is this area and how do we calculate that area? In our case, finding this area, we don't know how to find this area yet. We'll talk about that in 5.2 and 5.3. But what we can do is rather than finding the exact area, we are going to try to estimate this by putting rectangles underneath the curve. Why rectangles? Because we know how to find area of rectangles. That's about it. You can use really any other shape that you like. For example, there's something called the trapezoid method in which you try to fit the trapezoid underneath the curve, but we're not going to bother with that. Rectangles is going to be good enough, at least to get across the main idea. So rather than finding this actual area, we are going to find some collection of rectangles that we are going to fit underneath this curve. So what we want to find is indeed the area of these little rectangles right there. And of course, finding the area of a rectangle, well, that's just the length times the width, or in this case, width times height. The length of one side times the length of the other side. In this case, if you go through the notes, you can actually put any kind of rectangles you want underneath the curve. But when we deal with functions, what we want to do is we want to formalize it, we want to make the rectangle uniform in order to be able to find this quicker. So let's take, for example, a function. Let's take f of x is equal to x squared. We want to find the area underneath the curve, or rather estimate between 0 and 1 using 4 rectangles. So first thing first, let's try to get a picture of the graph and get an idea of what we're working with. So that right there is our graph of f of x between 0 and 1. And underneath this graph, I want to fit 4 rectangles. But I want to make, again, everything uniform so that I don't have to worry about having different size rectangles. So step 1, if I want to take a look at the width of the rectangles, the width of each individual rectangles. In this case, we are using 4 rectangles on an interval of 0 to 1, so we must divide that by 4 to get the width of each individual rectangles. So that's going to be b minus a over n, where n is the number of rectangles. So the width of each rectangle that I'm going to fit underneath this curve is going to have a width of 1/4. So the first rectangle will have a width of 1/4. So that from 0 to 1/4, that's going to be my first rectangle. All right. where is the location of my next rectangle then? Well, if the first one have a width of 1/4, the next one should have a width of 1/4. On the x-axis, where would that be? So you take 1/4 and then you add another 1/4 and you get 1/2. This right here, that's my second rectangle. And then again, if I am at 1/2 and I need to have another rectangles of width 1/4, where is the location of the next rectangle? Where should I end so that I have a rectangle of width of 1/4? Precisely at 3/4. You take the first term and then you keep adding the widths. So 1/4 plus 1/4 gives you 1/2. 1/2 plus 1/4 gives you 3/4. 3/4 plus 1/4 gives you 1. So what I mean is that we know our location to make our rectangle. Now, here what we want to do is we want to note that there are 5 points. 5 points on this x-axis where we can draw our rectangles. We only need 4. So we either use these first 4 points to estimate left rectangles, or we either use these 4 points to make our right rectangles. So what I want to do is let's just pick these left 4 points. Let's just pick these left 4 points. And let's try to draw these rectangles. If I start at 0, how high do I have to go to make my rectangle? Well, I'm not going anywhere. F of 0, that's going to give you the height. That's just going to be this line itself. If I start at 1/4, what is the height of my rectangle? If I know my rectangle starts at 1/4, how high is my rectangle? Well, my rectangle is going to be this high. And where is that point? That point is precisely f of 1/4. How high is it? F of 1/4 high. And then I complete my rectangle simply by drawing a line across and then a line downward. Now I go to my next point, 1/2. How high is this rectangle starting at 1/2? Well, I go up, draw a line to see where it intersects the graph. And where does it intersect the graph? Precisely at the point of f of 1/2. That I make my rectangle. So far, I have 3 rectangles. One starting at 0 to 1/4, which have an area of 0. One rectangle from 1/4 to 1/2, which have some area. The next one from 1/2 to 3/4, some area. And where is the last rectangle? Well, we start from 3/4. We find out where it hit the function f of x. That's going to be f of 3/4. And then we draw rectangles. And there you go. Those are the 4 rectangles that we are working with. So step 3, we find the height at each endpoints. So the height given the endpoint that we chosen is going to be f of 0, f of 1/4, f of 1/2, and f of 3/4. We don't care about the one we didn't choose one, so we just leave that alone. And now, step 4 is just finding the area of each individual rectangle. So to find the area of a rectangle, we take width times height. Well, if we take a look at the graph, the width will always be 1/4. Right there. Looking at the graph, the width will always be 1/4. What is the height? The height is precisely whatever the function is at the left endpoint, right there, that's height. That have a height of f of 1/4. And similarly, right here, that have a height of f of 3/4. So we just find the area of each rectangle that we see in the drawing. So the area of the first rectangle is going to be 1/4 the width times the height, which is going to be f of 0. That's our initial starting point, which f of 0 is just going to be 1/4 times 0 squared, which is going to be just 0. The area of the second rectangle is going to be 1/4 times f of 1/4, which is going to be 1/4 times 1/4 squared, which is going to be 1/64, I believe. The area of the third rectangle, the width 1/4 times the height given by 1/2, 1/4 times 1/2 squared. That is going to be 1/16. And finally, our fourth rectangle is going to be given by 1/2. The width times the height. The height in this case is f of 3/4. 1/4, 3/4 squared. Multiply that out, simplify all of that. It's going to be 9/64. So then we answer the main question. What is the area underneath this curve from 0 to 1? Well, the area is just going to be the sum, or rather not the area, but rather what is the estimated. Well, the estimated area is just going to be the sum of all of the rectangles that we found, the area of the rectangles that we found. And all of that is going to be equal to 7/32. So this step 1 through 4, that's the step that you want to use to find the area, well, to estimate the area underneath curves using rectangles. The only difference is that the question might ask you to find either the left endpoints, which start from a 0 to 3/4, or to use the right estimate, which is going to be from 1/4 to 1. But everything else stays the same. You are just finding area of rectangles. You are finding what is the width times the height. In this case, the height is given by the function evaluated at the endpoints.